So in this case, we are going to consider as a continuation from what we had on our interpolation, where you are to determine values from the steam table from a given pressure, a given temperature, which is not found in the steam tables. You do not have that. And we saw from different calculations and ways that we had using our interpolation. There are so many ways that you can actually apply that. Some of the other ways I explained that on our membership. So in this platform, or for this video that we are going to have, I'm going to consider using the general formula. Most of you guys, we are into calculations, so we understand much better when a formula is given. So let's say for a given temperature, whether it is a given pressure, but that pressure, we do not have it from our steam tables. If we consider in our previous case, we worked with 11,33 kilopascal, which we do not have. We have got 11 kilopascal in terms of the pressure. We have got 12 kilopascal, but 11,33 is not given. And for that pressure, you will notice that from even the question papers, they try to round off values, which is actually them applying it. But the exact thing that is supposed to happen is that you are supposed to interpolate for that to obtain values corresponding to that pressure, which can be our TS considering the values from our steam tables. Any corresponding value that is from our steam tables, from that, maybe from the pressure that is unknown, you need to determine the saturation temperature, you need the specific volume of the dry saturated steam, you need HF, these enthalpies, you need SF, and this from an unknown value, from the one that is not given here. So the general formula can help us to determine that which states or which is given as y is equal to y1 plus. All right, you understand me very soon. This is x2 minus x1 into the y that you're calculating here. You're going to find the difference y2 minus y1. So take note, what you're calculating is this at its initial value, y1, and this is the same bracket, y2 minus y1. So this part of x, what does it actually represent? All right, so you understand me very soon. So this is what we have from our formula. The x here, this x is the given value, the given quantity, which is not from our steam tables. We do not have that on our steam tables. So that's the required value position. All right. So let me write it this way. This is what you refer to as the required value position. So in actual sense, the quantity that you are given, like, is it pressure? But that pressure is not found from the steam tables, all right? So the given what? The given quantity, all right, which is not found from steam tables. We do not have that from our steam tables. We do not have that. Is your X there? Required value position for, okay, is it temperature? Is it pressure that you are given there? So it is the one corresponding to the Y value. So the Y value is the one that you are required to calculate. So this one is the required value to be calculated, all right? The required value that is to be what? To be calculated. to be calculated. The one that we are being asked, let's say for a given pressure, we want to determine any of these one. That is that is what I'm trying to say. From that, you want to find TS, V, whatever, any of these from the unknown value, I mean, from the unknown pressure that is not given, you want to find n of that. That is the y value, or maybe you're given temperature, you want pressure. So this y value is going to represent any of what we are being asked. All right. So that's y here can represent the enthalpies. So we have got enthalpies there. We have got the entropy can also represent the y value. It can be volume. We saw that we have got volume. We also have temperature. So it depends. When you are given temperature, maybe you want to find the pressure. It can also be pressure. It can also be internal energy on that one. It can also be internal energy. So that's the y value, what is to be calculated. So x now, this x that we have here, I want to start with x. Remember, it is the value that is the required value position, the given quantity, which is not found from our steam tables. Okay, so let's say it is pressure. From that x, we are going to have x1 and x2. This x1 and x2, they are from what? They are from x. So these are the boundaries. From x, x must be greater than x1, but less than x2. So what am I trying to say here? The x, remember, it is the one that you are given. You are given this, but only that we do not have it from our steam tables. So x1 and x2 now, they are the ones, the boundaries, they are what the boundaries for what you are given. So if you've got a pressure of 11,33 kilopascal, and this pressure is not given or is not found from your steam tables, then you're going to need the boundaries for that given pressure. So it's going to be P1 and P2 representing X1 and what? And X2. Let's say it is temperature that you are given, all right? You are given a certain temperature, but that temperature, you do not have it from the steam tables, all right? It can be a temperature. But that temperature that you are given, you need maybe to calculate the enthalpy from there, or it is volume from there. But you do not have the given temperature. Let's say a temperature of 91 degrees Celsius. We do not have that from our steam tables. So that is your x. This is your x, which is representing what? The temperature. So these will be the boundaries T1 and what? And T2 from that, which is representing your X1 and your what? Your X2. From the given value, you find the boundaries, what is in between. So these ones, we have them from our steam tables. T1 and T2, which is our X1 and what? And our X2. We have these values from our steam tables. So that's our X1, that is our lower value. So this is our lower value, which is what? Which is known. It is known from our steam tables, all right? Which is known from what? Steam tables. So that is the condition. The same with our x2, but only that x2 will be the upper value, all right? The upper value. And it is also known from what? Steam tables. We have that one from this consideration. It is temperature, it is pressure. You choose the values that are known from the steam tables. Let's say for 91 degrees Celsius. What will be the boundaries? You check according to what you have, all right? In terms of the temperature, if we check, we do not have 91, but we have got what? We have got 90 in terms of the temperature. We've got this 90 here. So meaning to say, you're going to consider it as part of your boundary, the 90 degrees Celsius. All right. If we move on, we also have 91.8 in terms of the temperature here. We've got what? 91.8. So 90 and 91.8 are the boundaries that we have. Those are the limits from what we are given. 91 is in between these two, 91.8 and this 90. So that is what I'm trying to say. If it is pressure, you do the same thing for the pressure. You just look you just look for the one that is what? In between. So those are the X1 and X2 values. The lower value, which is known from your steam table, and also X2 is known. So from this X1 and X2, you are going to find Y1 and Y2 from X1 and X2. So Y1 and Y2, this Y1 and Y2, this Y1, this Y2, this, it corresponds to what you are calculating here. Remember, Y is the required value to be calculated. So let's say you are dealing with the temperature. It means Y1 and Y2 will be temperatures. There will be temperatures. If you are dealing with the pressure, Y1 and Y2 be pressures. If it is volume, Y1 and Y2 will be representing what? Will be representing volume. So they correspond to the required value. So this Y1 is still Y1 and Y2. These two, they corresponds, all right, corresponds to what? To the Y value, to the required value, to the required value. They correspond to the required value. That is Y1 taken from what? Taken from X1, or corresponds with X1. So Y1 taken from what? From X1. Y2 is being taken from what? From X2. So if X is representing temperature, from that temperature, this is what I'm trying to say, from that temperature, what is the corresponding value? Maybe it is pressure, maybe it is volume. You take it that way. So that is what we have for Y1 and Y2. They correspond exactly to the required value. So if the required value is volume, it means Y1 and Y2 will be representing volume V1, V2. If the required value here is the enthalpies, maybe it is HF that you want. So it means Y1 and Y2, they will be representing enthalpies H1, H2, which is what? Which is from your HF. If it is pressure, it means there will be P1 and P2. That is what you are having for this Y1 and Y2. So with this, guys, you can answer any question with this very, 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 very short formula that we have here. We can answer any question from the required value position. X is what is important. That is the most important thing, X. This X that we had here. So let me just use this one. All right. Then what is required? Y here corresponds to Y1. It corresponds to Y2. It corresponds to this also Y1. That is what matters. That is what matters. X, X1, X, and X2, they correspond from what? From X. The required value. If it is pressure, it means this X1 will be representing pressure. If X is representing temperature, this X1 and X2 representing what? Representing temperature. What is required? If it is volume, it means this is volume. This is also volume. This is also volume. This is what I'm trying to say. So if you check, here is the formula that we actually applied here. This one, if you check before. But only that we are focusing on, right, is the enthalpy and what and the temperature only we are dealing with. No, it can be for anything. It can be for volume. It can be for temperature, whatever that you are given from the steam table. So let's consider the same pressure that we had before. I'm not going to change. Let us just consider the same and apply this formula. For an example, you are given a pressure of what? Given a pressure P of, given a pressure P, which is equal to 11,33 kilopascal. We worked with this one before, and this we do not have it from our steam table, but from that pressure, we want to find the corresponding HF, HFG, and also, yeah, let us just have the temperature. So it can be anything, volume, SG, whatever, guys, anything. So I'm just going to focus with these three. All right. So let us apply this into our consideration. The formula, using the general formula, y is equal to y1 plus x minus x1 over what? x2 minus x1 into that y that we have, but it's y2 minus what? y1, the change. So this is what you are simply going to consider. Remember, our focus is what? Is x, the one that you are considering as the given value, but we do not have that one from our formula sheet. That is what? That is your x, the quantity which is not found from your steam table. So that's the pressure of 11,33. We do not have that one from our steam tables. If we consider the pressures here, 11, all right, I think I showed you guys before. We have got 11 and 12. We do not have 11,33. So that is what is our x. That's our x. All right. So our x is what? The given pressure. So in our case, x is representing what? P. So that's, I don't know, guys. Let me just use this one like this, x. So that's P, pressure, which is 11,33 kilopascal. So I want to change this formula. So if x represents the pressure, remember x1 and x2, those are the lower value known from your steam tables, x1 and x2, from what you're given. If it was temperature, it means they represent the temperature. So if it is pressure like this, our x, if it represents what? Pressure. So it means P1 and what? P2. That will be your x1 and x2. Remember, your x is representing pressure. So the limits x1 and x2 are the limits of what you are given, that part that you're given. If we're given temperature, we're going to consider T1 and what? T2. So in our case, it's what? P1 and P2. So that's x1. It's simply our P1. All right. So that's our P1, which is the lower boundary of what? 11,33. So the lower boundary, just like what we had before, right? So what is the lower boundary here for 11,33? It is found between 11 and what? 12 on the pressure. So between 11 and what? 12. So 11 is our P1, the lower, all right? So that's 11 kilopascal. And the maximum here, the upper is what? Is 12. So that's your P2, which is 12 kilopascal. So that's representing what? Your x2. So you can actually change the formula, write the formula in terms of what? This. Your x is the pressure. So x1 and x2 also represent what? Pressure. So y, remember, it is what? The required value. So what is it that we are required to calculate? Let us start with HF. So if we are to calculate HF, it follows that our formula was going to change because Y is representing what? HF. So our formula is going to be HF is equal to Y1. The limit, if Y, guys, is representing H, the enthalpy, HF. So it means Y1 is the same with that H. So Y1 is simply representing H1 and Y2 is what? H2. The enthalpy is for what? For HF, H1 and H2. That is the concept. So in place of Y1, we are going to write what? H1. Since we are calculating H here, so it's going to be H1 plus X. Remember, X represents what? Pressure. So that's P minus P1, the lower value, into P2, the upper value, minus P1. All right, that's into Y1 minus Y2. Those are the enthalpies, the one that you're calculating H. So that's H2 minus H1, where these are representing what? HF. From the given pressure now, from the limits, from these pressures that we're given, P1, what is the corresponding value of HF there? That's your H1. So from P1, you're going to find the value of H1, which is the value of what? Of HF. Guys, we're calculating what? HF. We are focusing with what? With HF. So at 11 kilopascal, your lower value, what is the value of HF there? So at 11 kilopascal from our steam table, this is 11. The corresponding value of what? HF. We are on HF. So this is the corresponding value, which is what? 200. At 12, the corresponding value is what? 207, which is the maximum. So we need H1, which was 200. So that's at 11, that's 200. All right, so this is kilojoules per kilogram. Then H2 corresponding from what? From the 12 kilopascal, the upper one, it is what? 207, just like that, kilojoules per kilogram. So that's, we have got what? H1 and H2. And these values now, we can substitute them back into our formula and find our HF, as we have got our formula. HF is equal to H1 from that HF. HF at what? At P1. HF at P1 is what? 200. All right, plus P, our P, remember this one is the one that you are already given, but only that it was not from our steam table. So that's our 11, what? Our 11,33, this one, that's our P. Sorry, so that's, I'm just gonna write this 11,33 minus what? P1, or P1, the lower value, over the difference, the upper minus lower, 12 minus 11, into H1 minus H2, our H2 minus H1, 207 minus 200, just like that. So you're going to simply use the calculator in simplification, and that was going to give you 202.31. That's kilojoules per watt per kilogram, as we are dealing with enthalpy there. Just like that. You're dealing with HF. Know what you're calculating. Y, what is the Y value? So we're going to see that in order for us to calculate, if it was HFG, the second one, all right, let us move on to the second one. So this is the value that this one, this is the value of HF at what? That 11,33. When after interpolation, this is the corresponding value at what? 11,33 kilopascal, which is the exact value. So the formula gives us the exact value rather than approximating or rounding off this one to 11 kilopascal. It gives us the exact value corresponding to that pressure. This is what I'm trying to say. All right. So let us consider if it was HFG, you're going to see that all this, all right, it was gonna, if it was the second one for HFG, this HF is now HFG. So we now have this one as what? HFG. So you're going to see that our formula was not going to change. It was not going to change, only that you are working with what? HFG. So this H1 and H2, they are going to be taken from what? From HFG, since Y is representing HFG this time. So Y1, which is your H1, all right, and Y2, which is your H2. These ones are HFG. They are from what? HFG. So that's what you're going to have. At 11 kilopascal, your H1 is what? Your HFG. Since what you're calculating here, guys, is what? HF. That is what you consider from your steam table, what you're calculating. So H1 is what? That's from 11 kilopascal, but we need what? All right, we need HFG there, straight up to this one. This is our HFG here. So the value here is 2388. So you're going to take that value, 2388, All right, so that's 2388. All right, then H2 is still the value of what? HFG, but at what? At the upper value at 12 kilopascal. So at 12 kilopascal, what is the value of HFG at 12 kilopascal here? The value of HFG corresponding was 2384. So that's 2384. All right, so this is what you're going to have, 2384 kilojoules per watt per kilogram. So that is what you're going to simply have, guys, 2384 kilojoules per watt per kilogram. So that's the only difference. You are focusing on what? What are you focusing on? HFG. That's your H1 and H2. So you simply substitute into the formula, then you are going to find the value of what? HFG at the what? At the given pressure, which we do not have from our steam table. So our H1, the lower value, 2388 plus the P, all right, that's 11,33. That is 11,33 minus what? P1, which is 11 over 12 minus 11. This part is not going to change into what? H2 minus H1, the enthalpies that we had there, 2, 3. So that was going to be H2, which is 2384, 2384 minus what? H1, 23. That was going to be 2388, like that, all right? So this is linear interpolation using the general formula. You can find these values direct like that. So simplifying this, you're going to obtain the value of HFG from there, which was going to be 2386,68, all right, kilojoules per kilogram, which is the exact value, all right, at what? At that pressure of 11,33 kilopascal. This is what we have. Without approximating anything, we determine exact values using what? The linear interpolation. Just like that. So question papers, definitely it will be maybe one value that you're working with, or maybe two values. Maybe you want to calculate HF and HFG. You can simply use that formula. All right. Maybe it is temperature that you want. All right. Let us move on to the other one, which is what? The temperature. So if you are dealing with the temperature now, meaning to say the Y value, remember that is what to be calculated, the Y value, that is the required value. So meaning to say, if our required value, if our Y value this time, all right, if our Y value is representing TS, the saturation temperature, maybe it's TS that you're dealing with. So it means this will be TS, all right? So this is going to be TS is equal to, so here it's no longer H1 and H2 on this formula. Because of what, guys? Because our Y here corresponds to Y1, Y2. So if Y is representing TS, the saturation temperature, it means what is representing Y1, it is T1. That is your Y1. Okay, I wrote it here already. So let me just write it here. So Y1 is representing what? T1 from what you're calculating. And Y2 is what? Your T2, which are simply temperatures representing TS, your saturation temperature. Only that they are being calculated from where? They are being calculated from these pressures P1 and P2. That's why we have to name them T1, T2, but they are what? Our saturation temperature that we are dealing with. So meaning to say, at P1, our 11 kilopascal, at 11 kilopascal, this one, what is the value of what? Of T1, which is your TS. That is what you're going to need. All right. So that is the concept here. What is the value of T2? That is what you're going to need. So our formula was going to be adjusted. Instead of us using that H, Y1 is what? Is T1. Y2 is what? Is T2 minus what? Minus T1. So this will be your formula now. Just Understanding this, we are done. You can use it for any value. If it was volume, guys, if it was volume, it means your volume, whether it's Vg here, this was going to be V1, and this was going to be V2 minus V1. If it is volume, just like that. Anything, anything that is according to what you have from your steam tables, all right? If it is the entropy on its own, if this is Sg, this is going to be S1, this will be S2 minus S1. Corresponding to what you are given, what is it that you are given? The pressure. So that is it. So what is the value of what? Of T1? Because we already have those pressures, guys. What is the value of T1 and T2? Corresponding to what? To the pressures P1 at P1, 11 kilopascal. All right, let's check at 11 kilopascal. What is our saturation temperature here? At P1, 11 kilopascal. This is the corresponding, that's our TS in degrees Celsius. So that's 47,7, all right? 47,7. So that was 47,7 degrees Celsius. And T2 at what? 12 kilopascal. What is the corresponding? At 12 kilopascal, the corresponding temperature here is what? 49,5. So that's 49,5. So we're going to take that one. 49,5 degrees Celsius. So that is it. Let us simply use our formula straightforward. Since we have to calculate the temperature, so our TS is going to be T1 from what we have, 47,7 plus P minus, this is just a repetition, guys. Our P is 11,33 minus P1, which is 11 over what? P2 minus P1, 12 minus 11. All right, so that's 11 here into what? T2 minus T1. Our T2, remember, 49,5 minus T1, 47,7, just like that. So this formula can be used for anything to be calculated. Anything, guys. So it was going to be 48,294 degrees Celsius. That is by what? By interpolation. So we have used our linear interpolation to find the temperature which corresponds at what? 11,33 kilopascal. We were not having that. We do not have that, but we can obtain for that using this linear interpolation. So it can be used for anything as long it is part of your steam tables, right? So as long as it is part of your steam tables. Also, for the superheated steam, it can be used for anything, guys. Even for the superheated steam, we actually considered something like that from our superheated steam for those who watched this class. So it can be used for anything. So only that I was writing specifically for the enthalpies and temperature. But if you use the same concept using that, you see that that is where this was actually taken from this formula of our linear interpolation. So this is it, guys, our general formula. Let us try to apply it in as much as we can. Where we do not understand, let us communicate so that we can work on that part on a separate class. But for now, that is it till we meet again.